N1 V1 is equal to N2 V2. This formula is applicable only when the concentration is expressed in normality. Normality multiplied by volume of equivalence of the titrant is equal to normality multiplied by volume of equivalence of the pipetted outer solution. This is applicable only for normality. What is normality? Normality is the number of gram equivalents present in 1 liter of the solution. This particular calculation you should always remember because this is very important. What is molarity? Molarity is number of moles of solute present in 1 liter of the solution. 1 liter of the solution. Number of moles of solute present in 1 liter of this. How will you calculate number of moles? Number of moles equal to weight taken. What is the weight taken? Divided by molecular weight. Suppose I want to take 1 mole of hydrogen atom, then I have to take 1.008 gram of hydrogen. This is the weight taken divided by its atomic weight. So this will contain 1 gram atom, which is equal to Avogadro number of atoms, 6.023 into 10 power 23. But number of gram equivalents means number of gram equivalents is equal to weight taken divided by equivalent weight. What is equivalent weight? Equivalent weight is molecular weight divided by valency. The valency, it may be taken as the basicity of an acid or acidity of a base or the number of electron transfer. These are all the important ideas behind the practicals. நீங்க எவ்வளவு வெயிட் ஒரு சப்ஸ்டன்ஸ் எடுக்கிறீங்களோ அந்த வெயிட் அளவுக்கே ஈக்குவலண்ட் வெயிட் இருந்தா, அதாவது இப்போ ஃபார் எக்ஸாம்பிள் ஆக்சாலிக் ஆசிடோட ஈக்குவலண்ட் வெயிட் 63. 63 கிராம் ஆக்சாலிக் ஆசிட் எடுத்தீங்கன்னா that is called 1 gram equivalent. இந்த 1 gram equivalent substance 1 லிட்டர் தண்ணியில கரைச்சிட்டீங்கன்னா 1000 ml தண்ணியில கரைச்சிங்கன்னா it is called 1 normal solution. This idea you should always remember. இதோட molecular weight 126. அப்போ 126 gram oxalic acid எடுத்தீங்கன்னா that is 1 gram molecular weight. அத 1000 ml வாட்டர்ல கரைச்சிங்கன்னா it is 1 molar solution. அப்ப இதுல இருந்து என்ன ஐடியா கிடைக்குது? 1 molar solution of oxalic acid is 2 normal solution of oxalic acid. இந்த ஐடியா உங்களுக்கு வேணும். ஏன்னா 1 molar solution ப்ரிப்பேர் பண்ணீங்கன்னா அதுக்குள்ளார 2 gram equivalent இருக்குது. அதனால 1 molar solution of oxalic acid is nothing but 2 normal solution of oxalic acid. This idea is very important. Another important idea is, I want to ask you a question. இப்போ I'm taking hydrochloric acid. It reacts with the sodium hydroxide. Sodium chloride and water is formed. The enthalpy change accompanying this process is minus 57.3 kilojoule per mole, or it is minus 13.7 kilocalorie per mole. If you take a hydrochloric acid and sodium hydroxide, or nitric acid and sodium hydroxide, or you may take hydrochloric acid and potassium hydroxide, or you can take nitric acid and potassium hydroxide, whatever may be the acid and the base. Only condition is the acid should be a strong acid. What is a strong electrolyte? It is getting ionized easily. And the base should also be a strong electrolyte, which is getting ionized easily. When you neutralize a strong acid and a strong base, whatever it may be, then the enthalpy of neutralization is always a constant. It is minus 57.3 kilojoule per mole. Why it remains a constant for all the strong acid and strong bases? It is because HCl, as it is a strong electrolyte, it remains as H plus and Cl minus, completely ionized. Sodium hydroxide being a strong electrolyte, it remains as Na plus and OH minus. So when they react, what is formed is sodium chloride, which is also a strong electrolyte, which remains in the form of Na plus and Cl minus. What is formed is water. So the enthalpy change of the reaction H plus OH minus forming water, this enthalpy change is minus 57.3 kilojoule per mole. Therefore, what happens, irrespective of the other ion which is present in the system, whether it is sodium or potassium or chlorine or nitrate ion or OH ion, whatever it may be, irrespective of the other ions which are present in the system, the neutralization is merely the combination of H plus and OH minus ion to form water. And the enthalpy change accompanying this process is minus 57.3 kilojoule per mole. But if you take weak electrolyte like acetic acid is a weak electrolyte. It ionizes only to a small extent to form an acetate ion and H plus ion. But this ionization is an endothermic process which consumes an energy of plus 1.2 kilojoule. Therefore, this plus 1.2 kilojoule has to be subtracted from the heat liberated, minus 57.3 kilojoule. Therefore, when weak electrolytes are combined to form salt and water, the enthalpy change accompanying neutralization decreases. So this particular point you should always remember. The strong acid, strong base neutralization is always a constant with a minus 57.3 kilojoule per mole. But if you take a weak electrolyte, then the value decreases. Weak electrolyte means either you can take acetic acid or you can take ammonium hydroxide on the base side. So weak electrolytes, they do not dissociate. Even though they dissociate only to a smaller extent. Therefore, the neutralization enthalpy decreases. This is another important idea you should remember. You take acid, base. If a weak acid is taken and which is titrated against a strong base, example, weak acid, acetic acid, strong base, sodium hydroxide. In such situations, phenolphthalein is used as the indicator. Phenolphthalein is used as the indicator. Phenolphthalein. Phenolphthalein is used as the indicator. This phenolphthalein is pink in base and is colorless in acid. When you take a strong acid and a strong base, when you take a strong acid and a strong base, even for which phenolphthalein is used as an indicator. When you take a strong acid and a weak base, strong acid and a weak base. Say, for example, you can take hydrochloric acid and a weak base, ammonium hydroxide is taken. Then methyl orange is taken. Methyl orange is pink in acidic condition and it is light yellow colored in basic condition. So this is how the titration is done. But you should remember a few equivalent weights. For HCl, the equivalent weight is 36.5. For sulfuric acid, equivalent weight is 49. Actually, its molecular weight is 98. There are two replaceable hydrogen atoms. The basicity of sulfuric acid is 2. Therefore, its equivalent weight is 49. For sodium hydroxide, equivalent weight is 40. And for sodium carbonate is a weak base taken. It is 106. So these are all the important ideas you should remember regarding the titration. Look at the question and read it carefully. 4.08 gram of a mixture of barium oxide and an unknown carbonate, MCO3, was heated strongly. The residue weighed 3.64 gram. This was dissolved in 100 ml of 1 normal hydrochloric acid. The excess acid required 16 ml of 2.5 normal sodium hydroxide solution for complete neutralization. Identify the metal M. Actually, this problem is taken from IIT entrance examination. Why I have taken this problem? Certainly, this problem is not going to be asked in NEET because this is a very big problem. You cannot solve this in 1 minute. Why I have taken this? This problem involves a lot of logic. In every logic, number of questions may be asked. Now, the metal that is taken is bivalent. That is the first idea. It is in the +2 oxidation state because the molecular formula given is MCO3. So metal is in 2+ oxidation state and the carbonate ion is a 2- oxidation state. This is the first idea. Secondly, when this metal carbonate MCO3 is heated strongly, watch closely, when it is heated strongly, what is formed is metal oxide and the carbon dioxide liberated. Now, this is actually 4.08 gram metal carbonate plus barium oxide altogether. The barium oxide and metal carbonate altogether weighed 4.08 gram. While heating, the metal carbonate has become metal oxide. Barium oxide has not changed because barium oxide does not undergo oxidation. So they put together, now they weigh 3.64 gram. Therefore, the weight difference is due to the liberation of carbon dioxide. So the weight actually lost is 0.44 gram. 0.44 gram. Which means that molecular weight of carbon dioxide is 44. I have already told you a logic. The weight divided by molecular weight will give you number of moles. Therefore, what is the weight of carbon dioxide? It is 0.44 divided by molecular weight gives 0.01 mole of carbon dioxide has come out. So 0.01 mole of carbon dioxide has come out means automatically this infers that metal carbonate taken is also 0.01 mole. So first idea is complete now. One idea we have found, the metal carbonate that was found in the mixture is of the quantity 0.01 mole. So this calculation involves the logic of stoichiometric equivalence and also the calculation of number of moles from the weight taken. So stoichiometric equivalence, the number of moles of weight taken, these two ideas now have got into the system. Now look here, this metal oxide, it can combine with hydrochloric acid. So that is what is the next step. It is dissolved in hydrochloric acid, excess hydrochloric acid. Excess amount of hydrochloric acid is taken, and naturally metal chloride might have formed. Metal chloride and water might have formed. So we have already concluded that the metal is in the +2 oxidation state. Suppose as I have taken excess hydrochloric acid, the metal oxide reacts with the hydrochloric acid forming metal chloride, and still unreacted hydrochloric acids are there. So I've taken 100 ml hydrochloric acid, and in the 100 ml, the metal oxide reacted, and the excess hydrochloric acid is titrated. I take the excess hydrochloric acid in the conical flask and it is titrated against 2.5 normal NaOH solution, and the equivalence point is 16 ml. Equivalence point is 16 ml. Therefore, you have to find out the volume equivalence. So 16 ml multiplied by 2.5 normal of NaOH is equal to, if it was 1 normal, what might have been the volume? So that is equal to 40 ml of 1 normal acid. 40 ml of 1 normal acid. So 40 ml of 1 normal acid is now in excess. Actually, I have taken 100 ml. So 60 ml of 1 normal hydrochloric acid is reacted. It is reacted. 60 ml of 1 normal hydrochloric acid is reacted. This 60 ml actually reacted with 60 ml of 1 normal hydrochloric acid is reacted with barium oxide and the unknown metal oxide. Because not only barium oxide, metal oxide got converted to metal chloride, barium oxide is also got converted to barium chloride. So the 60 ml is used by both barium oxide and metal oxide. Now, barium oxide and metal oxide. But we have found barium oxide plus 0.01 mole of metal oxide, because this 0.01 mole we have calculated from the number of mole of carbon dioxide released. This reacted with 60 ml of 1 normal hydrochloric acid, 60 ml of 1 normal hydrochloric acid. This 0.01 mole of metal oxide might have reacted with 0.02 mole of hydrochloric acid, because one metal needs 2 chlorine atoms of normality 1. Therefore, the volume of equivalence for this is 0.02 mole into 1000, that is equal to 20 ml of 1 normal hydrochloric acid. Therefore, what happened? 1000 ml of 1 normal hydrochloric acid is containing 1 mole of Cl minus and H plus ions. Therefore, 2000 ml of 1 normal hydrochloric acid is containing 2 mole of H plus and Cl minus ion. Therefore, 20 ml will contain 0.02 mole. This is how it has come. 0.02 mole. Why this 20 ml has come? 1000 ml of 1 normal hydrochloric acid contains 1 mole of Cl minus ions. So 2000 ml of 1 normal hydrochloric acid contains 2 mole of Cl minus ion. So 20 ml of 1 normal hydrochloric acid will contain 0.02 mole of Cl minus ion, which is here. So out of the 60 ml, 20 ml is for metal oxide. We don't know. Remaining 40 ml is for barium oxide. 20 ml is for metal oxide and the 40 ml is for barium oxide. So 40 ml of HCl corresponds to, what is the weight of barium oxide? So 40 ml of hydrochloric acid is corresponding to, see, if you take 1000 ml 1 normal, then it is 1 gram equivalent. So it is for barium 138, oxygen 16, equivalence by 2, so 77 gram. If it was 1000 ml of 1 normal hydrochloric acid, 77 gram of barium oxide might have reacted. So what is it for 40 ml? If 77 gram is reacted for 1000 ml, for 40 ml, 3.08 gram of barium might have been reacted. So barium oxide plus metal oxide is equal to the residue weight. It is already given. It is 3.64 gram. From the titer value, this is found to be 3.08 gram. Metal oxide, I don't know, X. This is equal to 3.64 gram. Therefore, X is equal to 3.64 minus 3.08. So the metal oxide weight is 0.56 gram. Metal oxide weight is 0.56 gram, which means 0.01 mole of metal oxide weighs 0.56 gram. Therefore, what will be the weight of 1 mole? It is 0.56 divided by 0.01. It is coming out to be 56 gram. So metal oxide molecular weight is 56. So metal atomic weight is 56 minus 16. So metal atomic weight is 40. And the metal with the atomic weight 40 is calcium. Therefore, the mixture taken is barium oxide and calcium carbonate. See, this problem has involved a lot of logics. I suppose you understand this entire problem. Clear? Look at the question. A compound liberates the carbon dioxide with the sodium bicarbonate and also gives color with a neutral ferrichloride solution. The compound can be. In order to liberate carbon dioxide with a sodium bicarbonate solution, it has to be a carboxylic acid. It has to be a carboxylic acid. And in order to give color with the neutral ferrichloride solution, it should be phenol. So the compound which contains a phenol and the carboxylic group is this. Here it will not work because this is alcoholic, not phenolic. Here it will not work because this is phenolic, but acid group is not present. Here it is only phenol. Therefore, the correct answer is it should contain both the phenolic group and the carboxylic acid group. So the correct option is this.